São Paulo, Department of Computer Science, and I'd like to talk with you about some work that I did in the last 2 years in a company, a Brazilian startup called Elo7, and this talk is organized in patterns. So for those who are familiar with patterns, we just had the PLOP conference before Splash, and the kind of presentation and the organization of the concepts are in patterns. So what is a pattern? A pattern is a kind of way to document solutions in specific contexts. So every pattern is a rule of 3 parts: context, and a problem that occurs in this context, and a solution for this problem in this context. So what was the context of my work? So I was working in a startup, and this was the architecture that we had when I started to work in 2012, in January, in the beginning. So we had just 2 servers. It was one application server, and it was a web-based application with a MySQL database, and both of the servers were dedicated in a data center. And the MySQL was a huge machine because it has all the photos, all the pictures of the products that we sell. More than 1 million products sold in the platform were in this database, so they became a huge database. And also the user statistics data, and of course the core data was in MySQL database. And we had some, the code was basically all the code inside this application server, WAR application, JEE application. So image processing, back office, business logic, and core, login, card, emails, search, everything was inside the same application and in the same code base. After 2 years, this is more or less what became this architecture. So basically we have something around 30 servers in the cloud, and most of the applications got decoupled in different components. So we have the core in one application server, the search moved to another server, the login is specific for other application server, and so on. And now we developed also a REST API for some operations, not all, but some of the operations, especially the cart. And we developed a queue for asynchronous jobs, the photos, and all other file assets. We moved to S3, cloud-based storage. And the back office, the back office business logic, we developed a new system in decoupled from the main application. So, and we also put some user statistics using DynamoDB, and the user sessions we moved to Memcache. So this is more or less what became our architecture, and I'm going to talk about 7 of the patterns that we kind of discovered, because a pattern is, actually you identify them, they are there, you just identify and you see some other people using the same way to solve the same problems in this similar context. So most of the patterns can be seen here in this diagram, but I will talk briefly about each one of them. There are 7, and of course it's not a complete catalog. We need to improve it and to create a whole pattern language. So this is future work, but I will talk about some of the problems that we solved and we tackled in this specific way. So in my case, I organized the patterns with these 3 topics. So you have a context, you have a solution, and why did we use this solution? So basically the context was you have a web application and you have many large files, photos, videos, music, some large files, and you do not want to store, definitely you do not want to store these files in your database as it was before. So you want to avoid blob columns, you don't want to worry with disk space because you have to manage the free space if you are managing these files by yourself, increasing disk space, increasing database size. These are very complicated and sometimes difficult work to do. And of course, you want to have backup of all these files. So basically what it did was we moved to S3, and there are some options, also cloud storage. Microsoft has a solution for cloud-based storage. And there are REST APIs that you just need to make a call to these APIs to store the files or to get the files or to modify them. They're pretty standard, easy to use, and you do not have to worry with availability and performance. All these worries goes away when you put this kind of files. There are static files, they have cache solutions inside this storage. So everything you need for this kind of service, it's there in the cloud. So we moved all our images to these servers. And then after that, we also needed to process these images sometimes. So when a user uploads a file, he needs to redimension the image. We need to create thumbnails, many different sizes of thumbnails. So there's a huge process of processing these images. And remember, there are more than 1 million products. Each product has more than 5 images, so it goes 5 million images. And if you have five different sizes, big, small thumbnails, so it goes more than 25 million files. And it's a good idea to process all this thing in the background. So here comes the second pattern, which is a queue-based solution to process async jobs. So basically, we started with this file processing, but we also moved some other processing to this solution, this queue-based solution. So you need a fast response to the end user. You don't want the user to wait you for processing some very complicated things. So you put this processing in a queue, and the user, you can give to the user some feedback about what you are doing, and he can come later with the result. And we use it, in this case, we use it Sidekick, which is a queue based on Ruby language, but there are all the other solutions, RabbitMQ and other Java solutions to do this. And it's very simple. You just have a small piece of code in Ruby which does what you want to do, and you have a Redis server. And basically from the producer side, so we have this producer which puts what you want to process in the queue, and there are many consumers, so you can scale this in tens of machines. If you need more processing, you have an amount that is increasing in some specific moment of the day. You can create instantaneover new instances in the cloud and start processing fastly. So it's you automatically have failover in these solutions, these queue solutions. So if some job fails, it automatically restarts. So the old-fashioned way was to creating a thread inside your application server. This does not scale so well, and it also harms your application server because it will compete with the HTTP server to respond to users. So it's better to do this in other place. Another solution, so load balancing with main cache the user sessions. So basically you have there's one moment in your life that you have to expand your server, not vertically but horizontally. You need to serve the user with more than one server, so you are already using the biggest server you have, and it still do not have enough capacity to serve all your users. And also you do not want to have a single point of failure, so you need more than one servers. So load balancing is a very common pattern for serving to distribute the load between many servers. And what we did here was something more than just the load balancing, because the load balancing works perfectly if you have stateless application. So if your application do not have so much state for the user sessions, and sometimes you can use cookies for that, sometimes you just grab the information, have cache it all around, so you do not need the user sessions, a shared space where you can have this user information like card or who is logged in and other specific information about the user. And we had a legacy application, and most of the applications we see around, they have a lot of information in the session, and sometimes it's not so easy to remove, to make this application stateless. So you need to stay stateful for some time, and in this case, this does not scale so well, because you will be limited on the size of each server. And the main cache user session solution uses a main cache cluster. So the main cache cluster is scalable. You can have as many nodes as you want in this main cache server. And basically, the user gets stick to one Tomcat server, and the session information of this user is replicated to the main cache server, and is synchronized almost instantaneously. And if this server specifically goes down for some reason, and the user is obligated by the load balancer to move to another server, when the user arrives for the first time in this new server, the servers asks for this session ID, and if it does not exist, it goes to the main cache and asks if there are some information about this session ID for this specific user, and then it grabs the information just when it needs. So you can do hot deploy. So for example, we had 5, 3, 5, 4, depending on the moment of the day servers, and we could easily deploy the application during the day, and we put one server down, put the war there, restart the Tomcat, and then put the server back to the load balancing, then remove another server, upgrade the application, and so on. And so we can put different versions of the application. We can do deploy during the day, and for the end user, he doesn't feel anything. It's just like if nothing was happening. So, and it scales forever because you can use as many servers as you want. Another pattern is about cloud email delivery. So, some time ago, if you need to send emails, what you were used to do was you have your SMTP server. You just connect to it and you create an email and then send. And if you have lots and lots of transactional emails, you start to get some problem with that. So why? Because maybe you have to maintain these SMTP servers. If you use a third-party SMTP server, sometimes you get a limit for sending message. Most of the SMTP server do not give you much limit to send millions of messages per day. And you want these mails to be guaranteed that they are delivered. You want reports about their delivering. So again, we use a cloud email service, which has a REST API, much easier than using the SMTP protocol, which is okay, you can use it, but REST are usually very friendly, especially for people who program for web. So they are used to call REST services. And you do not have to manage the SMTP server. It's easy to program. You are free from spam. If you use the right services, it will give you one IP address, and if the emails that you deliver are actually true emails that the user wants to receive, most of the users are okay on receiving transactional emails like, oh, you have a new order, you just put this new order, your order is shipped, some notifications by email, so this is not spam, this is something that they want to receive. So this is what we call transactional email, or when the user is registered or other operations from the daily usage of the platform. And with these tools, there are some services, the Amazon SES, and there's also SendGrid and Mandrill, and these are the three most known platforms for sending transactional emails. And you have reports from opening, you can track when users actually open the email, so it's a very complete platform. All of these three, they have some difference, but they are very good, and you do not have to worry about sending emails anymore. Just do a REST call and you're done. The next pattern, cloud logging. Of course, you have lots of logs in your servers, and since you become bigger and bigger, you have more servers, so you have more logs, more machines to log in and to see the logs, so it's almost impossible to have access to all the logs. Just go into the machine and do a grab inside a log. So if you have 1 or 2 machines, it's fine, but if you have 30, if you have 1,000, it's impossible. So you need some place to centralize the logs and some scalable way to have your logs. So what you need to search the logs, you need to have access to it instantaneously. You do not want the developers to to log in the production servers to have access to logs. So what you do is use a log-based log service, and it's as simple as putting one configuration line in Linux. You just put one configuration line in the syslogd configuration file, and that's all. You open it uses a UDP port, which is does not consume a lot of bandwidth. It's very does not hurt your application, does not harm your application, and you do not want to do manual copy of the files. If you would have to go into the server and copy to somewhere else, it's very tedious, and you do not have to care about disk space. The servers, they can scale as much as you want, and some of them are expensive, but it's just a matter of money, not a matter of managing. And sometimes it's better to spend some money than having to spend money with a professional who have to manage all the servers and these files. And also, we use the Splunk Cloud Storm solution, but there are some others, Logly and other solutions, which I put in the paper, that index the log file so you can fastly search for anything you want. You can create alarms based on peaks of something that appeared that was not expected in the logs and things like that. And the next pattern, real-time user monitoring, also similar to logging. So together with logging, the user monitoring is very important. Of course, logging is a kind of monitoring, but you also need to monitor user-specific data. So how many logins did you have in your application? How many searches, visits per page? And you want this real-time. Why real-time? Because if something happens to your server, or if you have an abnormally behavior, you can identify it instantaneously and you can fix if there is some problem. You can fix it quickly. So in our context, we have more than 1 million users. We do many deploys per day and the user behave differently. We don't know why. Sometimes there's a holiday, sometimes there are some specific thing that is happening and the user starts to behave in a different way, and we want to know what is happening. And also we have a very complex infrastructure with 30 servers, different components, so maybe one component will fail, but you want to know what exactly is impacting the end user. So we do not also have 100% of test coverage. And even if you have it, it does not guarantee that you will not fail, because coverage and tests do not guarantee you will not fail. Sometimes in production the environment is different. Sometimes you have some piece of the architecture that is some network problems. So you have many different kinds of problems that can happen in production. So when you monitor this thing, you can track if, for example, you know that the search volume is 1,000 per minute, and if for some reasons from 1 minute to another now is not, you expect it to be 1,000 and it was 100, you have a problem there, and you can easily see in charts. You can go and track the application and look the logs. Then you can also create alarms based on this real-time user monitoring. And the last pattern is about a comparison between PaaS and IaaS. When should I use platform as a services instead of infrastructure as a service? When we talk about cloud, of course, we have SaaS, we have software as a service, and also PaaS and IaaS. But and you need to choose between these solutions depending on what is your moment and what kind of application you serve. So we had all the three in our company. We have PaaS, IaaS, and SaaS. And sometimes you'd better to choose PaaS. And here is when I understand that you should do PaaS. So if you do not want to worry about your infrastructure, you do not have many system administrators, you just want to let with the cloud and you just want to write code to focus on your business, especially when you are a very small startup and you're just beginning, you can't waste your time with infrastructure, with technical things. You need to deliver quickly. If infrastructure is your business, then maybe it's better to use IaaS. And sometimes you do not trust in PaaS servers or PaaS services providers. You want to have more control of your infrastructure, and you have the knowledge, and you think that it's better for you to to stay in control of the things, you want to pay this price, then you should go to IaaS. So this is a pattern. Repeating a pattern is not, this is not something that you should take as a true, a universal truth. It's a kind of a guideline. So you have this problem in this context, so you should apply this, because this was seen from many other places that work at some time and then should probably work for you. And if it does not work, of course you can create another pattern and improve these patterns. So this is what I had to talk with you. Thank you very much.
Okay, questions?
I have one.
Okay.
So, what you didn't talk about is when you have some problems with your cloud infrastructure. You have at least one example